Hey class, this is Mr. Roberts. One last question I wanted to share with you as you're prepping for your test tomorrow. This question came up during the wager round in Math Monkey today, and wow, I was well, it's kind of ugly, but I was a little disappointed in not you, just disappointed that we're so afraid of ugly answers. And I hope that you get to where you can embrace answers that are not what you think answers should look like, perhaps. If I was tackling this problem, right, the thing that I would do first of all is get rid of these fractions, right? And to do that, I would multiply both sides by the lowest common denominator. Now, the way I tackle looking at these is I break these numbers down into their prime factorization. So, for example, if I'm looking at, go back there. If I'm looking at a number like, for example, 2, or 8 rather, that's 2 times 2 times 2. 5 is a prime number, and 4, of course, is 2 times 2. So when I look at this, I look at each one of these separately, right? I know that I need 3 factors of 2. I need a factor of 5. And the reason why I don't need these additional factors of 2 is because they're going to be taken care of by these 3 factors of 2 over here. So the lowest common denominator here for these fractions is 8 times 5, which is 40. So I'm going to multiply both sides of this equation by the number 40. Let me erase all this. Now, of course, when I do that, we need to realize that when I'm multiplying both, it's an inequality. And it is a positive 40, so I don't have to worry about having to flip the direction of the inequality. On the right hand or the left hand side, I have two terms, right? Here's one term and here's another term. And over on the right hand side, there's a single term. Remember, when we multiply a side of an equation by a particular value, we have to multiply all of the terms by that value. So I'm going to need to multiply each of these, right? The 3x minus 5 over 8, and then the minus 4 minus 5x over 5, and the 3 minus 2x over 4, each by 40. So let's start one piece at a time here, I guess. If I multiply the first one, right, 40, I guess I'll put it over here so I can see it as well. If I multiply 40 times 3x minus 5 over 8, I can see that there's a common factor here with the 40 and 8, right? In fact, 40 divided by 8 is equal to 5. Is that coincidence? No, we designed it this way. I've now killed this fraction. So this first term is going to become 5 times the quantity of 3x minus 5. The next thing I have is there's subtraction. So I'm going to put this minus. And now I'm going to do the same thing. 40 times this 4 minus 5x over 5. 40 divided by 5 is equal to 8. So it's going to be minus 8 times the quantity of 4 minus 5x. And then on the right-hand side, I'm going to multiply again both sides by the 40. 40 divided by 4 is 10. So I end up with, this is greater than 10 times the quantity of 3 minus 2x. Already I just feel so much happier because I don't have any fractions at all. And this looks way more, rational. Actually, it looks less rational, doesn't it? So let's apply the distributive property. It looks like 3 times here. So the first time I get 15x minus 25. And then be careful, it's a negative 8. So that's going to give me negative 32. 4 times 8 is 32. Plus 40x's. And then this is going to be greater than 30 minus 10 times negative 2 is negative 20x. Combining like terms on the left-hand side, I've got here a, let me get my color pen. This is so cool. Look at this. This, the 15x and the 40x are like terms on the left-hand side. And also, let me get another color like this green. This negative 25 and the negative 32 are also like terms on that side. So when I combine those all together, 15 and 40 would be 55. So I've got 55x. And then I've got negative 25 and negative 32. If I combine those, that's going to be negative 3, 4, 5, negative 57. So minus 57. I haven't even grabbed my calculator. I'm shocking myself. Let's see. And then this is going to be greater than 30 minus 20x. So I'm going to minus. That's Interesting. Look at that. I can't. I think I might have a problem with my device because I had a hard time writing this negative symbol right here. But it is 30 minus 20x. I'm going to add 20x to both sides. So I'm going to add plus 20x over here and plus, geez, whoops, plus 20x over here. I cannot write in this area of the screen. I can't do it. 20x. Let's see if I start inking. Okay, it's almost as some spots. Well, I'm sorry about this class. And see, now I can't erase it. Anyways, I need to add 20x to both sides, so maybe it'll let me write it here. No, here. That it's registering that now as the eraser instead of the pen. Plus, plus, plus. Plus 20x. I don't like that. Okay, on the left-hand side, I've got 55 plus 20, which is going to be a positive 75x. That is going to be greater than 30. Just 30. Why 30? Because I combine those terms. Oh, I got a minus 75 over here, or 57 over here. You know, let me slow down and make sure I got this right here. So I added 20x to both sides, and 55 plus 20, 50 is 75. And then I add 50. I'm going to now add 57 to both sides. So I get that 75x is greater than 87. That's 30 plus 57 is 87. What the heck? That's a terrible looking answer. Let me grab my calculator and look at, so x is going to be, x must be greater than 87 over 75. So let's look at that. 87 divided by 75, enter. 1.16. I think that reduces as a fraction. Let's see, what is that? 29. Oh, that's not very, it's not great. I can reduce it to 29 25ths. Let's see. X. Yeah, it's like this area of the screen, no writing is allowed. Once I'm writing, though, it's okay. It's just it can't start writing there. I said 29 25ths. So x's have to be greater than 29 over 25. Now, I'm going to show you another way to check this. I did a checking of a problem yesterday, and it kind of freaked me out. I got a better technique I want to show you. So, and actually, I haven't rehearsed this, so I hope I don't embarrass myself. I'm going to take the number 29 divided by, Mr. Roberts, you always embarrass yourself. All right. So that's 29 25ths. I'm going to take that number and I'm going to store it into the variable alpha A. Second, I don't know, alpha A. No, see, you are embarrassing yourself. Into alpha A. It didn't take the A. Oh, there it is. Okay, so what that gives me is now anytime I refer to this variable A, it's going to give me 1.16. So if I hit alpha A again, it's right there, 1.16. Okay, so how can I use that? Well, I can use this as, I'm going to go in this numerator. I've got 3 times A minus 5, and I'm going to now divide that by the number 8. Okay. And from that, I'm going to subtract 4 minus 5 times A. So open parentheses, 4 minus 5 times alpha A. And I'm going to close the parentheses and divide that by the number 5. Now, when I do that, this left-hand side gives me this boundary condition of 0.17. 0.17. What I'm going to do now is I'm going to compare that with what I get when I evaluate the function on the equation on the right hand side, and they should be equal to each other. Although 0.17, you know, x will never equal 1.16. It can't be. It has to be greater than that. But definitely this tells me if at least the equality is right, or if the it tells me the boundary is correct, and then certainly greater than that point then would be my solution. So let's look at the other side here. I'm going to open parentheses again, 3 minus 2 times x, 2 times, and I stored that value in alpha a, close my parentheses, and then divide by the number 4. And I get, and that's also 0.17. So what I've convinced myself is that 0.17 is the value that gives me this boundary relationship right here, right? Where this side is the same as that. From this point on, then any value of x that's bigger than 29/25 will cause this number to be larger than the one on the other side. Anyways, this problem came up in Math Monkey, and I'm sorry that I got to figure out why I can't. My doodling's not working right here. This is a major bummer. This is Mr. Roberts. Have a nice evening.